All right, let's take a look at question number one. Do college students enjoy playing sports less than watching sports? A researcher randomly selected 10 college students and asked them to rate playing sports and watching sports on a scale from 1 to 10, with 1 meaning that they have no interest and 10 meaning they absolutely love it. The results of the study are shown below. Assume a normal distribution. What can be concluded at the 0.05 level of significance? Okay, so we've got 10 students kind of listed out over here, and this is their score for what they think about playing sports versus what they think about watching sports. And so these are matched up. So we have matched pairs for this one. So this first person gives a score of a 2 for their preference for playing sports and also a score of 2 for watching sports. But this student actually prefers watching sports over playing sports. And if we look kind of further over, we have a student who actually prefers playing sports over watching sports. And so it's not consistent all the way across. Some students have equal scores. Some students have a lower score for playing sports versus watching sports. And some students have a higher score for playing sports than they do for watching sports. So when we're looking at the question, it's saying the results of the study are shown below and what can be concluded at the 0.05 level of significance. So they've given us an alpha level of 0.05. And let's see, for the way that we're going to write our hypotheses, did they say something about preferring one over the other? Do college students enjoy playing sports less than watching sports? So if we decide that the playing sports is our group number one, and our watching sports would be our group number two, then when we're talking about writing the before and after scenario, we need to come up with a difference between these scores when we do the matched pairs. So what we did with the matched pair samples is we had to enter the lists into the calculator. And so we did an L1 for one of the lists, and we did an L2 for the other list, and then we used those to find the L3 by doing an L1 minus L2. So what we want to do here in terms of the calculator, you're going to go ahead and hit your stat button and go into edit, and that's going to pull up your lists. Make sure they're all cleared out, and under L1, you're going to enter 2, 4, 7, 3, 4, 3, 5, 6, 2, and 2. Then under L2, you're going to enter all of these scores for watching sports. So you're going to enter 2, 6, 10, 7, 3, 1, 5, 10, 4, and 4. And once we have the L1 and the L2 in there, you're going to go ahead and you're going to highlight L3 in your calculator. And when the L3 is highlighted and you hit enter, what it's going to do is it's going to let you now have L3 equals at the bottom of the calculator screen. You're going to want to enter the second button and 1, because that's going to let you put L1 in there. Then you're going to hit the minus sign, and then you're going to hit the second button and 2. That's going to let you put in L2. So at the bottom of your screen, it's going to say L3 equals L1 minus L2. And then you hit enter, and it's going to create that L3 list for you. And in your L3 list, it's got the difference between the L1 and the L2. So you should have 0, -2, -3, -4, 1, 2, 0, -4, -2, and -2 in that L3 list. So once we've got that L3 list, we're just going to let that sit for a second. And then we're going to go ahead and move forward with the rest of our questions here. And then we're going to pick up with the calculator part in just a minute. So what type of test is this? And what calculator function will you need to use? So for this one, this is a paired or matched pairs t-test. We also said dependent sample is a different way that we could say that. So I'm going to call this a matched pairs t-test as the type of test that we're going to do. And then what calculator function do we need to use? This is where we end up just using the regular t-test in the calculator. So in the calculator, this is just the regular t-test. So not a two samples t-test. This is just the regular t-test, which is going to be option 2 when we actually get there, but we're not quite there yet. All right, next question. What are the null and alternative hypotheses for this example? When we're talking about the matched pairs t-test, we're going to use that mu sub d as the parameter that we're going to be writing down. So I'm going to write down the null hypothesis and the alternative hypothesis. And so what they said was, do college students enjoy playing sports less than watching sports? So that would mean that we would have a smaller value for the first number than we do for the second number. If we have a smaller number for the first number than we do for the second number, then when we go ahead and take the difference of those numbers, we're going to get a negative number. So we're going to write that mu sub d is less than 0. Because if they like playing sports less than they like watching sports, then when we do the difference between the numbers, we're going to get a negative number. And this is how we say it's going to be negative. We say it would be less than 0. If that's the alternative hypothesis, then for our null hypothesis, we can go ahead and turn that around, and we can say that this is greater than or equal to 0 there. Other option is to just write an equal sign. What is our test statistic going to be for this one? We're going to need the calculator to actually get the test statistic, but I know it's going to be a t. And then the next thing it's going to ask for is the p-value, which we're also going to need the calculator for. So we're ready to do the calculator part. So now we're going to go back and hit the stat button on our calculator. And you're going to arrow over to tests. And you're going to select just the regular t-test, which is option 2. So the regular t-test, hit enter. And then because we actually entered our data into lists, where it says input and it gives you data or stats as a choice, we want to hit data. So go ahead and hit enter on the data. When you arrow down, then it says mu sub 0. For that mu sub 0, the value that needs to sit there is a 0 because that's the number that we have in our hypotheses. We're going to keep a 0 there. So it's probably already got a 0. You don't need to change that. Then you're going to arrow down to list. And it might have L1 in there as the automatic. We don't want L1 in there. The list that we want is the difference, which we put under L3. So I'm going to go ahead and clear that out. And I'm going to go ahead and hit the second and 3. If you hit the second button and then the 3, it's going to enter L3 for the list. Then we're going to arrow down to frequency. We just want 1 there. And then for the next row, we have to choose either not equal to the mu sub 0, less than the mu sub 0, or greater than the mu sub 0. We always go back to where our alternative hypothesis is, and we use whatever sign is in there. Our alternative hypothesis has a less than sign, so we want the second option or the middle option for this one. So go ahead and hit enter on the middle option, and then arrow down to calculate. When we hit that button, we're going to get our t value of negative 2.14 if I round it. And my p value is going to be 0.0303. Okay. So what decision should you make is going to come from us comparing that p-value to the alpha value that we set up here. So our alpha is like 5 pennies. Our p-value is 3 pennies. So that means that our p-value is less than our alpha value. So I'm going to write that. P-value is less than our alpha. So if our p-value is low, the null must go. So we're going to reject the null hypothesis. And instead of writing that out in words, You could also just write reject H sub 0. That would also be appropriate. So what is our conclusion in this case? We're going to say there is sufficient evidence at the 0.05 level, or you could say the 5% level of significance to suggest, and then we always go back to the alternative hypothesis to figure out what to write next. Our alternative hypothesis is that students enjoy playing sports less than watching sports. Okay. So again, why were we able to make that decision? We got our p-value and it was smaller than our alpha of 0.05. When your p-value is low, the null must go. So we are going to reject the null hypothesis. So we always start that sentence with there is sufficient evidence. The particular level we're using for this one is the 5% level. And then we always go up to whatever we said was the alternative hypothesis. And if it's helpful, what we said was this was less than 0 meant that playing sports had a lower score than watching sports did. So we said there is sufficient evidence at the 5% level of significance to suggest that students enjoy playing sports less than watching sports. That's where that less than 0 sign came from.